So density is defined as mass per unit volume. Its symbol is rho. So SI unit of density is kilogram per cubic meter, or in English unit, pound per cubic feet. The specific volume is 1 over density rho. So it's the reciprocal of density. So specific volume is volume divided by mass. So unit is cubic meter per kilogram, or in English unit, cubic feet per pound. So here pound is a pound mass. So both the density and specific volume are intensive properties. In thermodynamics, we often use molar basis to present the amount of substance. So mole is the amount of a substance, and some thermodynamic systems convert chemical energy of fuels into thermal energy. So this chemical reaction equation is the combustion of methane. So methane combined with air, and it produces carbon dioxide, H2O, water, and nitrogen. So the coefficient here, 1, 2, 1, 2, 7.52 denotes the number of mole. So 1 mole of methane gas reacts with 2 mole of oxygen and 2 times 3.76. So it's 7.52 moles of nitrogen in air. And it produces 1 mole of carbon dioxide and 2 mole of water and 7.52 moles of nitrogen. So mole is defined, number of mole N is defined as the mass over substance divided by molecular weight. The actual mass of a substance can be calculated number of mole times molecular weight. So 1 mole of methane is 16 grams. Since the molecular weight of methane is 16, molecular weight of oxygen 32, and this is nitrogen 28, CO2 carbon dioxide 44, H2O 18, nitrogen 28. So unit is gram per mole, or we can say kilogram per kilomole. So later in this course, some thermodynamic properties will be expressed in terms of kilomole. So you should understand the concept of mole. (1.6) Pressure. So when dealing with gases and liquids, pressure is an important property to define the state of a system. So pressure is defined as a normal force exerted by a fluid per unit area. P, pressure, equals F, is a normal force, divided by A. A is the area. So pressure in a fluid at rest at a given point is the same in all directions. The SI unit of pressure is the Pascal, or Newton per meter squared. So 1 Pascal is 1 Newton per meter squared. But the 1 Pascal is a relatively small unit. So we use different pressure units. 1 bar equals 10 to the 5th Pascal, or 0.1 megapascal, or 100 kilopascal. 1 atmospheric pressure, ATM, denotes atmospheric pressure. This is the standard atmospheric pressure at sea level. So 1 atm is 101,325 Pascal, 101.325 kPa, or 1.01325 bar. And this equals 14.696 psi, or 760 millimeter mercury, or torr, T-O-R-R, or 29.92 inches mercury. So it will be useful to memorize the atmospheric pressure in different units. And the bar is useful to use. 1 bar is 100 kPa, and 1 atmospheric pressure is 101 kPa, which is very close. So 1 bar 100 kPa, close to the atmospheric pressure. And 760 millimeter mercury. So this, see this diagram. This column filled with mercury, and the height L is 760 millimeter. And this corresponds to the atmospheric pressure. If we replace this mercury with water, actually 1 atmospheric pressure corresponds to about 10 meter of H2O water. So mercury is about 13.6 times more dense than water. That's why the height of mercury column is shorter. And here is a question: what instruments are used to measure pressure? So we use pressure gauge, manometer, and pressure transducer. They are the common pressure measuring devices. Second question: what is the lowest possible value of absolute pressure? Just 0. When it's a perfect vacuum, the absolute pressure is 0. We need to distinguish between gauge pressure and absolute pressure. Absolute pressure equals atmospheric pressure plus gauge pressure. Or we can also write it in these two ways. So negative gauge pressure is called a vacuum. But in practice, we measure the pressure of a system relative to atmospheric pressure. So if the pressure is above the atmospheric pressure, it is the gauge pressure. If the pressure is below the atmospheric pressure, it is the vacuum pressure. So see this picture. So here is the atmospheric pressure. If the pressure is above the atmospheric pressure, it's a gauge pressure. If the pressure is below the atmospheric pressure, it's a vacuum pressure. See the picture of pressure gauge and vacuum gauge. So it has a 2 scale. One is PSI and the other one is kPa. So pressure gauge needle turns clockwise as the pressure increases. See the vacuum gauge, it also has 2 scales, kPa, the other one is inches mercury. So vacuum gauge needle turns counterclockwise as the pressure decreases. Also note that the negative values, negative 100 and negative 30, negative 30 inches mercury, and or negative 100 kPa. In English unit, we add the letter A to indicate atmospheric pressure. So PSIA denotes absolute pressure. So we can write 14.7 PSIA. So we can tell this is the absolute pressure. 14.7 is the absolute pressure. G, the letter G denotes gauge pressure. So if it's 14.7 psig, it's the gauge pressure. So if the atmospheric pressure is 14.7 psi, absolute pressure is 2 times 14.7 psia. In SI unit, we don't add letter to distinguish between the absolute pressure and gauge pressure. So you may need to present it clearly whether it is an absolute pressure or gauge pressure in SI unit. The manometer is used to measure pressure. So U-shape manometer is used to measure the pressure difference between the two ends. So U-shape manometer is filled with liquid, and when both ends are open to atmosphere, this is open, then there is no pressure difference between the two ends. So the fluid level in both tubes are the same. If one end of the tube is connected to a tank and the other end is open to the atmosphere, so we use manometer to measure the pressure of the tank. So pressure at point A, this point here, the pressure at point A is the tank pressure. So neglecting the gravitational effect of the gas in the tank. So PA equals P pressure of the tank. So we need to determine PA. So pressure at point A and point B are equals. PA and PB are equals. Because the pressure in a fluid does not vary in the horizontal direction within a fluid. So again, PA equals PB because the pressure in a fluid does not vary in the horizontal direction within a fluid. So we just need to determine PB. PB equals pressure of the tank. So what is PB? PB is, so PB here is P atmospheric pressure plus hydrostatic pressure of the liquid, which is density times gravitational acceleration G times the height, length of the column, L. So pressure of the tank equals P atmospheric pressure plus hydrostatic pressure, rho G L. Temperature is a very important thermodynamic property. It is necessary to have a precise temperature value in order to define the state of a system. There are several types of temperature measuring devices. So what instruments are used to measure temperature? Liquid in glass thermometer, thermocouple, bimetric thermometer, thermistor, and pyrometer, or infrared thermometer. We as engineers are interested in knowing how things work. So what are the mechanisms and what causes the device to read the temperature? So first, liquid in glass thermometer uses the volume expansion of the liquid that is dependent on temperature. So if the thermometer is brought into contact with a hot object, the heat is transferred to the liquid inside the thermometer. So as the liquid expands, we can read the temperature through the thermometer scale. We used to use mercury in the thermometer, liquid in glass thermometer, but these days alcohol is commonly used to replace the mercury. Thermocouples consist of two dissimilar metals joined together at each end. So when the temperature is different between the measurement junction and the reference junction, voltage is produced, and voltage is converted to the temperature. In bimetallic dial thermometer, the bimetallic strip is wound in a helix form. So deflection of the strip with temperature causes the rotation of the strip at the free end, and it is attached to the shaft of the pointer, and the scale is provided to indicate the temperature. Thermistor has a resistor whose resistance is dependent on temperature. Pyrometer or infrared thermometer measures the temperature by sensing the radiation emitted from an object without making direct contact. Zero law of thermodynamics. It describes if the two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. So thermal equilibrium means there is no difference in temperature between the system. So here consider a thermometer as a third body. So if the thermometer measures the temperature of an object A, and the same temperature was read by the thermometer when it's reached at thermal equilibrium with an object B, then we can conclude object A and B are also in thermal equilibrium. So this is basically how we use a thermometer. So this seems to be very obvious, but it is the basis for measuring temperature. The SI unit of temperature is Kelvin, and it is also called an absolute temperature. And there is no degree symbol in Kelvin, so we don't add a degree symbol in Kelvin, but we add degree symbol in Celsius, Rankine, and Fahrenheit. And it also has the conversion equations between the temperature units. And also note that the temperature change in Kelvin equals temperature change in degree Celsius, and temperature change in Rankine same as temperature change in Fahrenheit.